Yo, what's good, y'all? There's a lot to catch up on today. Genuinely, a lot of things to catch up on. I've been off for about a day from posting videos. I think the last video I posted was my performance in the contest. By the way, that leads us to the first news, which is me becoming blue. Now, I wouldn't treat this as anything crazy because I might drop back. I'll probably come back up if I do. Anything other than purple for now, it doesn't really mean too much to me, I think. Achieving purple is kind of a different story, but anyways, I guess that's good news. My name color now matches my profile image color, which is really nice. It's cool. I definitely feel myself getting better. That leads us to our second news, which is we have finally escaped the contribution 0 friend of 0 users. We now have one friend. No idea how to check who that is, because apparently you can't check who friended you on Instagram. It's more of like a following feature, but whatever. So whoever that one person is, if you're watching this, props to y'all. Props to you, not y'all. And I'll do a little bit of catching up on the problems we've been solving. I've only solved one more because I've been working on this side project, which I'll also talk about. But before that, we have solved tree requests. I did make a video on this, I think. I'm not sure if I posted it or not, but tree requests. If I didn't, I'll post like my previous process, and I quit on the 15th of June and I picked it up again, okay? Now I'll tell you what happened. I came up with a general idea and I thought that general idea was right. But I kept getting wrong answer, and I did come up with a fix, but I was just brain dead that day because I was stuck on this for too long. And I didn't give up, I just delayed it, I guess. This was my code for the last submission of that day. Before I started implementing my new method. One really dumb part. I have no idea why I used maps here. Like, I don't know. I don't know what I was thinking at that time. I was that stupid at the time. Okay. But anyways, my fix was to not sort these, but essentially rebuild a version of the given tree in a way that like we can modify it and actually use binary search on it. And I did that. I basically just, instead of immediately creating an adjacency list, I made a different adjacency list, and I made the adjacency list we'll be using with BFS and just labeling these. And then I just came up with a decent script, but I got runtime error. And the runtime error lies somewhere inside here. If you didn't notice, it's when r equals 0. The binary search kind of fucks up. So I added a condition to check that over here. If level h.size equals 0, that means there's the set we get is an empty set, therefore it's technically a palindrome. So that satisfies our conditions. So I did that, but I got wrong answer. This was my code, by the way. So I was like, well, maybe it's not only when it's empty, when it's size 1 as well. That might be a sort of a tricky binary search case, so I also added that for safety. And then I went through that, but I got wrong answer again. I don't exactly remember how I fixed it here. So I was goofing around. Until, oh yeah, I remember. I added another condition here relating to like after the binary search. I checked like the difference between R and L to see if everything's safe, because it might not be safe. And I added this line right here. Very simple line, but I added that. And I got, what was the verdict? I got time limit exceeded. And I'll tell you why I got time limit exceeded. Theoretically this runs in a very borderline time, because my code runs in n times log n, which would be 500,000 times 20 times 20, which is pretty damn borderline, especially considering we only have 2 seconds, right? But I did see a few optimizations. First of all was changing all of these vectors into C-style arrays or C-style arrays of vectors to remove like vector overhead a bit. And also the slowness that comes with it. I wasn't really sure how to take care of this, but I just kept this whole thing. And then a big fix was reducing this. Now it always costs 0.20, even though it's constant time. Let's just say 0.20, okay? It always costs 0.20 to run find par, which is just log n, okay? But sometimes h isn't that big. In most cases, h won't be that big. So I fixed it to the right way of using these C-style arrays first of all. And doing this, we just iterate until h is 0. And I was like, yeah, this must be the answer, but I got memory limit exceeded, and I started tripping the hell out here. Because the only part that would cause memory limit exceeded in this code would be this. Now, this is a prefix array, and the dimensions are really funky. I could have put 26 in the back, but I just felt like doing this. I was basically drunk at the time. I wasn't drunk, but I wasn't on alcohol, but I just felt that my mind was sort of drunk. Had that drunk sensation to it. And I was like, And I looked at this for a while. And I was looking. I couldn't see how to change it into a C-style array because it has to be dynamic here for it to save memory. Second of all, if this was a C-style array in the worst case, it only takes up like 500,000 times 26, which isn't near the memory limit. Now the problem is the vector overhead, and I didn't know how to solve this, so I just searched it up. How do vector overheads work, and why is this memory limit exceeded? And I did some research, and I found that it's just pretty dang expensive, you know. I don't really know how to explain this part. I'll have to dive deeper into it alone, but yeah, this sort of... I had to switch spots, y'all. Someone came in the room, so... Anyways, back to the point. So I was like, damn, I really think I need this 3-dimensional element. But at the same time, I was like, we need to somehow reduce the 26. And I was like, how, you know? And I was kind of stuck there for a while. And yeah. Until I was just reading through my code over and over again, looking for optimizations. And then I realized, wait, all I'm tracking here is whether if it's odd or even. And whether it's odd or even, I know that like adding odd and odd is even, and adding even and even is odd, even and even is even, you know, the basics. And I was like, then that means I can represent it in zeros and ones. So first of all, the immediate thought was to just change ints into bools, but bools for some dumb reason cost the same as ints. And I also thought of using a bit set, but there is no reason to introduce bit sets to this problem. Rather, I can just represent 26 bits as one int, you know? So I can reduce this to a 2-dimensional vector, which saves like 26 times memory. Hold on, y'all. Yeah, I'm back. So I just came up with a way to do that. All you need to do is use a bit flip here. Since odd, even. Yeah, you get the point. And here, just do a little bit of this. I bet this could be simplified, but I just based this off my old code. And yeah, that led to AC. Borderline time. This might even not be the way you're supposed to solve this problem, considering the number of optimizations I had to do. I mean, this was the only main optimization, if we're being real, but still. Actually, I'll check the tutorial right now. I did go over this once because I was stuck here. No, I was stuck here, and I was wondering if I was even on the right track, and I read DFS, and then oh, okay, I'm probably on the right track.